Good morning, my YouTube viewers. It is Crystal here, and I'm just here this morning because I wanted to do a code review. And basically, what I'm doing a code review is on one of Kaggle's community competitions because Kaggle started having community competitions. And so I decided I was going to do a code review on Friends IMDb rating prediction. So if we come over here, because I've got my page up for competitions, you can see that there were only 11 people that joined this competition. And I scored 10 out of 11. But still, nevertheless, even though I scored 10 out of 11, it still was a good score nevertheless because it was 0.41384 and I only had one attempt. So you can look on the leaderboard. So I'm down at the bottom of the leaderboard, but I only did it once, and some people, whoever scored the highest, he had 11 attempts. So we'll come over here to my submission. So I'm being honest and letting you know that I'm second to the last. I had the penultimate to the bottom score, but it still wasn't a bad score. It was 0.41384 was the score. And so what I'm going to do is I'm going to go over the code for this with you just in case you want to do it. And the first thing that I did, they didn't give you all of the data sets. I'll say that the data sets were not very good that they gave, and the data sets had lots of just needed lots of work. It had to be cleaned a lot, but the data sets were not accurate, and because the data sets were not accurate, I had to go into this website here called Friends, and then I had to, if you come over here, this gives you all of the listings, all of the, when the episodes aired. So it gave you when all of the episodes aired, and then you could also list it as a CSV file. And when you listed it as a CSV file, I had to save it into a Google Word document. And then when I saved it into a Google Word document, I was able to upload it into the Kaggle notebook. So I just wanted to show that to you, that I had to actually upload another CSV file to actually get the information that I needed. Sometimes when you enter competitions, they'll tell you that you can use any file you want. And so what you have to do is you have to go through the system, and then you have to look for the CSV file that you want, and you can upload it into Kaggle and use it. And that's exactly what I did. So that's why I'm bringing this to your attention, so you'll know that that's something you can do. It was really, really difficult to do because it was designed to be difficult. That's why you only had 11 people enter the competition, because it was designed to be difficult. But I did it. I entered the competition and I scored the penultimate low one, but at least I scored. I got on the leaderboard because that's what's important, getting on the leaderboard. So the first thing we're going to do is a problem statement. They didn't give you a very good problem statement in the competition, so I just said this is a natural language processing problem based on the Friends TV series. And then what I wanted to do is I wanted to load my libraries. So what I did was I imported NumPy, which enables you to do mathematical calculations, and it also creates NumPy arrays. I imported Pandas, which creates and maintains data frames. I imported Matplotlib, which is a graphics library, and it enables you to plot data points onto a graph. And I imported Seaborn, which is a higher level graphics library that performs statistical graphs, but you can also plot the data points onto a graph as well. So now what we're going to do after we have loaded our libraries, we're going to load the data sets, and what we're going to do is we're going to go in and using the OS library, and we're going to go in and we're going to select all of the files that are actually in the operating system that you need to use to complete this competition. And as you can see, there's a lot of files. You've got the train file, the test file, and the CSV file. And you've also got this file that I uploaded that's a text file, friends, episode, date, friends, episodes. So that's the file that I uploaded, and that's the file that I had to use because it gave you the dates of all the episodes, and you need that. So I was able to upload a file. And don't forget, whenever you're entering competitions, sometimes the competitions say that you can use whatever file, another file, and then whenever you use another file, you have to upload that file into the system. And then after I've looked at all the files in the system, in the operating system, I read the data sets. So we use pandas to actually read the data sets. And so you can see that I read all the data sets that I needed to use. So we've got train, we've got title, plot, ratings, date, total reviews, and you've got train info that tells you what the columns are all about. So the date column is an object, and that's going to need to be converted to an actual date. So what we've done here is we've taken this date and we've converted it to a date. Train date equals PD to date time train date. So you can see it's been converted to a date. So I also needed to create another column calling it ID, and the reason for that is because the test file had an ID but the train file didn't, and the test file and the train file need to have the same format if you want to make predictions. So you've got your test file, ID, title, plot, date, total reviews, transcripts, breakings. So you've got transcripts on the test file that you don't have on the train file. So we're going to have to take the transcripts and we're going to have to put them into the train file. So you can see that these files were not designed very well, so you have to do a lot of work on the files just to get them to go through the system. So the test file, we had to convert the date to a date as well. So you can see that. And then now we've got the Friends episodes. This is what I have uploaded. You had 240 episodes. You had then the season, the episode, the air date, the title, and the TMTV maze link. So what we were most interested in was the season and the episode and the air date. So Friends air date, so we converted that to a date. So everything needs to be converted into a date. And then you're looking at the season's info because I converted it into a date. So now you can see that the date is a date time. Now what we've done is we've filled everything. We filled all the non-applicable rows with a 0, and we've dropped all of the non-applicable rows. So everything that has a non-applicable in it has been dropped. Now what we're going to do is we've got each seasons. We had 8 seasons. So you had to append all of the seasons together. So you start with season 1, and then you append season 2, 3, 4, 5, 6, 7, 8. So we've got a total of 8 seasons. So we've got, and rather than having 8 small data sets, we've got one large data set that we can work with. And so you can see the seasons here. Seasons will tell you it's a season, the episodes, and the transcripts. So you can see that these data sets that they give you are not complete, and that's why I had to upload another data set in order to complete this competition. So again, with seasons, we're going to fill all of the non-applicables with zeros, and then we're going to drop all the non-applicables. And then what we're going to do with the seasons and the episodes, we're going to convert because the seasons and the episodes were float in seasons. So we're going to convert those to integers to make them the same as the Friends episodes dataset. So the Friends episodes dataset is we're going to create a column and call it S episode, and it's going to be the season plus a dash plus the episode. So you can see we've created another column with the season and the episode because we're going to be using that, or I thought we were going to use it when I made it. And then that was Friends episodes. And now we're going to do seasons episodes, and we're going to use it the exact same way. So now we've got a column in Friends episodes and a column in seasons that are the same format. And now what I wanted to do is on the seasons transcripts, I wanted to remove the special characters from the transcript. So I removed everything that was a backslash and an N, which I think that just sort of like, because I wanted the transcripts to be the same as well. So if you come over here to the test file, if we can find the test file. So you can see that the transcripts on the test file had these special characters as well, but I wanted to get rid of the test special characters. Probably should get rid of them. I might go back and do that now that I think about it. So we got them. So what we did was we removed the special character from seasons. So that's what we did. You can see it had all those. So now what we're going to do is we're going to map the title to seasons, and we're going to use Friends episodes to do that. Seasons title equals seasons S episode dot map Friends episodes dot drop duplicates S episode dot set index S episode title. So now what we're going to do is we're going to take the title and we're going to add that to the seasons data frame because I thought I was going to need it. So now what we're going to do is we're going to take the date and we're going to map that to the seasons as well. Seasons date equals seasons S episode dot map Friends episode dot drop duplicates S episode dot set index S episode air date. So now we've got the date in here in the seasons file. So So now we're going to map transcripts to train and test. Let's see. So train transcripts equals train date dot map seasons dot drop duplicates date dot set index date transcripts. So now we're going to put the transcripts from seasons into the train file. We're going to use mapping to do that. And we're not going to need to do that on the test file because the transcripts are already on the test file. So now what we're going to do is we're going to define the columns in test and train because the data set needs to be in the same format in order to get it to make predictions properly. So the column titles equals ID, date, title, plot, transcripts, total reviews, ratings. And then so train equals train dot reindex, columns equals columns titles, test equals test dot reindex, columns equals column titles. So you can see train has ID, date, title, plot, transcripts, total reviews, ratings, and test has the same thing. So the train and the test files have the same format now. But what I would like to do is I think I'm going to go through and do it again. I'm going to take these next lines out of the test file because it looks like the next lines are still in the test file. So that's what I'm going to do. When I finish this code review, I will go ahead and do that on the test file because it's still got it in there, and my accuracy may improve if I get it out. But I won't do it now. I'll do it just as soon as I'm finished with this code review. Then I'm going to analyze the target. You can see that your target is going to range anywhere from 7.0 to 9.5, but most of them are in the 8th region. We're going to do a box plot of the target. You can see that this is your box plot, that the center is around 8.5. So it starts around 7 and it ends around 9.5 with your center in 8.5. Now what we're going to do is we're going to combine our train and our test together. So you can see now the train and the test are combined. And so you can see that I didn't remove the next lines in the test set. So that's one thing I'm going to do. I'm going to go through and remove the lines in the test set to make sure that they're all the same because those extra characters might make a difference. And then we're going to define the target, and target equals train ratings. We're going to define our text. Text equals combi transcripts. We're going to count the words that you have to process. It's 879036. We're going to process the text, and we're going to process the text by converting all the text to lowercase, remove special characters from the text, remove hashtags, remove characters less than 2 words, and then I used to remove the stop words, but I'm not going to remove the stop words anymore because the stop words has the word not in it, and not makes a big difference. So I decided that I wasn't going to remove the stop words anymore. And then the count has gone down to 605438. Now we're going to remove frequently used words. And now we're going to put in an apostrophe dictionary. So all the words that have apostrophes are changed or spelled out without the apostrophe. Okay, now what we're going to do is we've designed the function, and what this function will do is it will take all of the words that you want to replace, and it will take the words that need to be replaced, and it will replace those words with the words that you want to put in there. So we're going to use that function with the apostrophe dictionary. And now we're going to remove rare words. Rare words are all words where you've only got one word, and when we remove the rare words, the number count goes to 411225. Now we're going to use natural language processing with Spacey. So we have to install Spacey, because Spacey is not automatically installed in Kaggle. We're going to download the English dictionary in Spacey. So now we're going to do our natural language processing now that we've installed Spacey and we've installed the English dictionary. So we're going to import Spacey and import Spacey CLI. And then now we're going to import Spacey, and we're going to import Core Web LG, meaning it's a large data set. And then we're going to do some more work. So we're going to take the token and we're going to convert it to the vector. I'm going to do some work on this as well. I'm going to hash out these print statements because they're just cluttering up the program. So now we're going to take a sentence to vector using pipe. And you've got 300 columns. There it is right there. Now we're going to define our X and our Y variables. So Y is your target, and an X is text vector up to the length of train, and X test is text vector from the length of train to the end. I'm going to select my model. I decided to use K nearest neighbor. Has only 24% accuracy. I'm going to predict on the test set. And then I'm going to prepare my submission, and they didn't give us a submission file to use, so I had to create my own submission file. So that was submission equals pd.dataframe, submission ID equals test ID, submission ratings equals prediction, submission to CSV, submission CSV index equals false, and then submission. And then so basically that was it. And then here's my submission. Well, it's all in the 8s. I mean, I suppose in order to improve the score, I suppose I could try to use a different model. But I might do that. And obviously, when I finish this code review, I'm going to go through and clean up that text file a little bit, because I just noticed that and I don't like it. So I like everything to be pristine, so I'm going to clean that up. I'm going to hash out some of those print statements so you don't see all the words, because the words are cluttering up the program. So that's it for my code review. I'm going to go ahead and conclude this video because I've been talking for almost half an hour, just talking about this code. So if you like my video, please like, subscribe, and share. I would like to thank all of my subscribers for supporting my channel. Thank you so much for watching my video, and I look forward to making more videos for you in the future.